We're tackling the problem daily temperatures, and we want to try and solve this with minimum complexities of ON time and ON space. In this problem, we are given an array of temperatures representing daily temperatures. We need to find, for each day, the number of days we have to wait until we see a warmer temperature. If there is no future day with a higher temperature, then we're going to set it as 0 instead. So, I hope that you understand this. This is one of the most important problems in the course, and we'll be referring to the solution used frequently in future problems. So, your options for an optimal solution here are A. Binary search, B. Monotonic stack, C. Dynamic programming, or D. 2 pointers. I'm going to pause for a couple of seconds while you think about your choice. So, for those of you able to get it, congratulations. And for those of you who just want to see some code, the answer here is B. Monotonic stack. Looking at the brute force approach, we could iterate through each element in the array, and then, for each element, iterate through the rest of the array to find the next warmer day. That's viable, and it would involve nested loops and a time complexity of ON squared. However, it's obviously not the best approach. The monotonic stack is a very important one to understand. So, let's take a look at our optimized solution. In this, we're using the monotonic stack, and it allows us to solve this with time complexity and space complexity of ON. I'm going to go straight into the line by line for this problem, so that there's a clear understanding. First of all, we're calculating the size of our input array using SZ, and then creating a vector called result of size SZ, and it should be implicitly initialized to 0. Here is our stack, and this stack will keep track of the indices of the temperatures, and it's going to be heavily used in the for loop. Our for loop iterates over each index in the array, and inside our loop, we're going to be checking if the current temperature, temperatures I, is greater than the temperature at the top of the stack, that is, temperatures stack.top. Before we do that, we make sure we have a stack that's got something in it, or the code will fail. In any case, if the current temperature is greater than the temperature at the top of the stack, it means that we've found a warmer day. So, we update the waiting days for the temperature at the top of the stack, like so. And because it is a while loop, we will keep updating the waiting days until we either find a warmer day or the stack becomes empty. Once we're out of the while loop, or one of these conditions fails, we'll push the current index I onto the stack and then go to the next element in our array. I strongly recommend checking out the debug version of this if you're not getting it, and make sure that you fully comprehend this. After the loop, we will have processed all the temperatures and stored the waiting days in the result vector. Finally, we just return that result vector. LeetCode provides a few helpful test cases that will help you understand if your approach is correct, or perhaps you can use it to compare the test cases to the code here. If you're still struggling with understanding this solution, then please check out the description of this video and have a look at this Udemy course, and in particular the daily temperatures problem which is listed within it. It'll really help you understand this and many other problems of this type. In fact, anything involving a monotonic stack. So, that's one more problem-solving session completed with Coding CardSharp, where we've used monotonic stack to solve the daily temperatures problem. There is a lengthy explanation as to why this works in the application itself, and if you need extra help, we have the code available in a variety of languages. Python and Java are slightly more popular than C++ at the moment. In any case, that's everything for now. This course will be continuing with Next Greater Element 2. Thank you very much for watching.